All right, here we are. Let some folks pile in. Make sure the live stream is rolling. Not seeing anything come through yet, Justin. He says maybe 15-second delay, so let that go. Bill and Justin, Peridio Incorporated. We love what you're up to, and we'd love to partner.
We are live
We're
on a
live.
Friday. Happy Friday. Hey. Yeah.
Happy Friday. It's been a wild week. What have you been up to, Justin?
Huh. Programming some devices. It's been fun. Hardware shows up and I just make it work. Um, yeah, we've got some really cool stuff to be able to demo today. I'm really excited about what we've been up to and the devices that we've got a chance to be able to work with recently. Um, yeah, it's pretty cool stuff.
I was yeah, I'm psyched on this demo. I was in New York earlier this week and then kind of hit the ground running back on Wednesday morning. It feels like I've lived 5 lifetimes up till now, and then been awesome to watch this demo come through on the way to today. And yeah, really excited to dive in. So we'll let a couple more people jump in. I can't quite see. Let me see. Not sure how many people are actually viewing right now, but we'll give it a couple more seconds and then we'll get started. Justin, what's a fun fact about you that everybody here should know?
Um, well, I am semi-obsessed with coffee, I guess, but more so than other people. Yeah. There's those of there's those that are in the space that would go so far as to say, "Oh, I've got an AeroPress," or "Oh, I hand grind my own beans and do pour overs." But I think at this point, I pretty much have like every piece of coffee brewing equipment. Actually, no, you recently outdid me. You picked up a new one, all right,
The loop,
yourself. Yeah, the
the
loop.
hoop, the loop or the
Yeah,
hoop. Yeah,
that
yeah.
one was
No.
pretty cool. I don't have that one yet, but yeah.
What's your favorite roaster that folks can go check out?
I would say Brandywine Coffee Roasters. They've been doing some cool co-ferments. I recently picked up a bag of one that's been co-fermented with rose. That's been
Oh
fun.
my,
Yeah.
wow.
It's like nice. It's like a rose water coffee. It's good.
That's counterintuitive. Yeah, they do a lot of fruity flavors. That blueberry punch. All right, cool. Well, let's get into it. I could yak all day about coffee with you, but I think people want to hear something else. So, for those of you that are just joining us and maybe new to Peridio or Avocado Linux, my name is Bill Brock. I'm CEO of Peridio. Today, we also have Justin Schnack, our Chief Product Officer, and Justin is spearheading the initiative that you're all here to see today called Avocado OS. What we're doing at Peridio is accelerating the deployment of enterprise applications to real hardware. And we want to get product teams, engineering teams into the application development loop and out of configuration and super hardcore build scripts. Been posting a lot on LinkedIn lately. I think people might feel that I'm a Yocto hater. We are not Yocto haters at all. In fact, we use it quite extensively. But our underlying premise is that we build Yocto so that you don't have to.
Hmm.
And Justin, I don't know if this is the right direction, but that's the guy. Yeah, cool. So, a couple things on Peridio, and we'll get into it. So there's really three aspects to our platform. There's Avocado, which we're going to talk about today, and then everything that we have is backed by an industrial grade, reliable, scalable, and battle tested platform called Peridio Core, where you can do OTA, fleet management, observability, all the things. And as we continue to push Avocado forward and provide even more rich functionality there, we'll be looping that into the centralized management plane, which is the core product. Everything here is boxed in very nicely with LTS. And so if you're looking at products on a 5 or 10 year horizon, we got your back. So Justin, why don't you page through more slides? Tell them what's up.
Yeah, as Bill mentioned, one thing that we're really excited and proud of moving that we've been working on lately, Avocado OS. It's really a culmination of what we've seen and experienced with spending, decades cumulatively in building and producing products out in the field, from industrial applications, consumer electronics, all across the board. And through those experiences, we found that embedded hardware development practices kind of were definitely didn't move at the same pace that you get your web development stuff from. And we reached a point where these worlds are starting to converge, but in a way that isn't necessarily conducive towards the kind of constraints that we deal with in embedded. So Avocado is born out of this concept that we want to be able to ship things quicker, but we don't want to do it in a way where we sacrifice the things that we really love about embedded devices. We need to be able to be power off friendly. Like, the power can just get pulled from these things at any time. They need to be robust, deterministic, reproducible. And with the dichotomy of choice between some building your own OS completely from start to finish and maintaining all of that burden versus maybe reaching for something that's off the shelf like a desktop environment, each have its own really detrimental trade-offs for both ease of getting started or long-term maintainability. And
And Linux is king, and that's very important to note. Like the customization, the benefits, the security posture you can have, you can't match it anywhere else. And Yocto and the patterns that it provides give you that scalability, durability, maintainability at scale that we don't see elsewhere in other tools right now. And so we're looking to bring those benefits forward to the application development teams.
Yeah, and generally this stuff is hard when you're building for these new kinds of products. That not everything is like a PC, and it's not all the same. Everything can be different, and so having that flexibility is important. And that's why we took this approach towards building Avocado on the concept that we build Yocto for you. Yeah, we're a binary distribution, but not in your traditional sense. Instead of offering packages that you'd install at runtime, those packages are used for you to be able to compose what you want your system to look like and in a build environment that we also maintain as well in our SDK layers. So what you're doing then is you're creating these things called extensions, and extensions are effectively just an overlay tree that would get applied to your system at runtime, right? And
So what are we showing today? What's up? So we got a industrial HMI in 10 minutes or it's free.
yeah, yeah. Today, we're going to be working on a product from Seed Studio over there. It's a industrial HMI product that they have. It's based off of a Raspberry Pi 4 compute module, and it's got this display on it. And there's a small version of this and a big version of this. We can see it on my desk here. I've got this is the reTerminal DM, the bigger version of 10-inch display. And this here is the reTerminal. It's a smaller form factor. It's a little less and different in the peripherals. Depends on your use cases, but yeah, we're going to be programming one of these with WebKit, like a browser, to be able to boot it up and show the speed at which you can kind of start to be able to get up and running and iterate with like UIs on these kinds of devices with like web technologies.
So, quick pause. Justin, you've been telling me about the reTerminal forever. You've loved this product. You've been a longtime fan. Justin, for those of you that don't know him, he travels to a lot of conferences, has done a lot of education. And one of the reasons we're excited about this product in particular is it's super accessible. Like you can go buy it today. It's Pi based. And so a lot of people are familiar with that. But it gives us and Justin the ability to give a UI and like a general experience for those who are looking to get into embedded Linux. And so maybe the web application developer that would want to do a nice little UI, React app, Flutter, or something like that can get up and running very, very quickly. But it's embedded. This is actually like an SBC behind the scenes, and all the patterns that you apply on this toolkit can be applied forward to other SOCs, other SOMs, other product lines as well.
Yeah, absolutely. I mean, what we have got here is the Raspberry Pi 4 as well, which these are based off of the compute modules of the same platform, and we make it really easy to be able to put together a single project and port between those different ones, just like Bill mentioned. The project that we're going to show today, it's available from that we're going to follow along with. It's available from like our new documentation that you can get up and started with as well. You can visit docs.peridio.com, and there's a provisioning section there for Avocado. And this walks you through some of the commands that we're going to go through live today. And we're also going to be using some examples from our Avocado EXT, Avocado-EXT on Avocado Linux over at GitHub. You can grab this repo and follow along with the example as well. Then, from if you have one of these devices. If not, I'd say pick one up. It's really cool, and there's definitely a nice pathway. Seed Studio did a good job with these, and you can even get them to operate as your CM for you. If you needed to be able to just ship these, you can white label them and put your logos on them and customize them to your needs. So really cool.
So do we get one in purple or green? That's the big question.
So yeah, we gotta go with the maybe half. We'll get one of each,
One of
right?
each. Sounds good. All right, so we're 10 minutes in. You ready to start the clock? You ready to get rolling?
Yeah, let's show some stuff off here. So
So, good.
first, let's start. As I mentioned, the Avocado X repo. We've got this WebKit UI in our runtimes repository here, and what you'll find is Avocado works off of these config files. And if you don't have one, you can actually get started real quickly with just calling Avocado init. That'll initialize with the CLI installed one of these config files. But this one's decorated to give us a little bit more support, right? So we want to make it easy for people to get up and running quickly. And so you can just open up one of these config files and get started by plugging in extensions that we pre-built. And so, Avocado produces some out-of-the-box stuff to make it easy to start working with certain like application stacks or development stacks. We have a dev extension that brings in a lot of development tooling to be able to make it so that you have SSH. You can have some tools available to you to kind of like debug and probe things. And we also have a WebKit one as well, which is a bit of a more heavy-handed one. That's WebKit's pretty big and it's a bit complex to be able to bring in. And if you have to ever compile WebKit, this is where the big time savings comes from that we'll be able to see as well. WebKit could take on a regular PC hours to be able to compile, but we're going to just be able to, as we mentioned, install it from package sources and get up and running. So we're going to get started with this application, and to show that, here I've got on the window on the left just a command line interface that we can use to just in that WebKit UI directory. And on the right, I have a terminal for the reTerminal that we have as well, right? So if I take a peek here, we're going to be working with this guy first, the smaller one, and we're just going to go through programming that. So on the left, I can start by typing avocado install, and I'm going to pass the -F, and that's going to just answer yes to everything. And you'll notice that we're going to go through the first setup. It's going to install the SDK and then make sure that all the packages are pulled down and installed. So this went through a run of output for each one of our extensions that we're bringing in. It installs the packages and creates those system roots of what the tree would look like, right? And then from here we can go right into. I should mention one thing that we have to do is set a target, right? So I exported avocado target equals reTerminal, and otherwise for each of these commands you can just pass --target and then retarget to a new machine right away that's supported with your config. So
What are the
that
targets we're supporting today, right now? So,
Yeah, for this example, we have supported targets for Pi 5, Pi 4, reTerminal, and reTerminal DM for this
okay,
one.
cool.
But that list will be expanding as well for anything that's got like a good HMI display. We can make this same project work across those different targets as well. So yeah, now we have our components installed. We'll call avocado build, and that's going to build. Oops, typing and talking. Avocado build. There we go. That's going to build all of our images, right? So we mentioned earlier that for embedded systems, we want things that are deterministic. And so we want to be able to have image-based updates. Avocado, the way that we work and structure the OS is that we have our root file system images, the things that you boot off of, they're extremely minimal. And they take up the first parts of the disk. And we A/B partition those so that you can get the earliest failure cases caught, like in the bootloader. And then the rest of the drive, we just partition as the var part, and that's formatted as butterfs. And that lets us put all of the extension images into there, which extension images are basically just raw file systems. They also support DM Verity and LUX-based encryption, features that were roadmapped to be able to move forward with on each of these targets as well. So
and
now that we've
one important call out about extensions is, and maybe you mentioned this earlier, I'm probably just thinking about myself and not listening, but this is not something we invented, right? These are from system D ecosystem and common like durable Linux technology. And so this is not some strange concept that we've built. We're just taking it to embedded.
yeah. Yeah, and it's with systemd, the system extensions under the hood let you kind of extend or patch up the user and the opt folder, and then there's conf configuration extensions that do the Etsy folder. And we kind of like expose that in ways that makes it really easy for you to kind of patch up wherever you need to get the runtime into this integrated perspective, right? So now that we've built everything, we can provision the device. And so to do that, we do have built-in support for provisioning over USB with these. So I'm going to use this command avocado provision. I'm going to tell it that I want to provision my WebKit UI runtime, and I want to use the USB provisioning profile. So this is kind of where it gets a little fun. So I'm going to pause on that command. We have to put this device into provisioning mode. One of the interesting bits here on this device is that the Raspberry Pi 4 compute modules, they have a boot switch that you need to be able to flip on them in order to be able to put them into provisioning mode. And then you can provision them over the USB-C port that's on the device. Now, to get to
Okay.
that boot switch, you'll need screwdriver, take the back off, and pull off the heat sink, and that'll show you the module. And then like way down in here, right at this spot, is a little switch. And we're going to flip that down to be able to program this device. And then what we're going to do is we're going to plug in this with USB, and I'm just going to connect the Ethernet cable to this one right away as well. And so we'll just set this guy back up here for now. And back over to our terminal. Now that
Okay.
we're connected with USB, we can press return on this. And every target's a little different, right? So in this case, the reTerminal can be programmed over USB. It's an interesting way that they do it. That puts it into USB boot mode. And because our SDK, we run this in a container on the host, we have really fine control over the environment. And so the tools that Raspberry Pi gives us, to what you can see here, it's booting the device over USB to just give it a kernel that knows how to be able to put it into mass storage device mode. And then we just wait until it appears as a storage device. And then once it does, we can continue with the provisioning procedure. So here it says that it found it. There's a 29-ish gig eMMC now that's mounted. And saying if we want to be able to overwrite the data, we'll answer yes. And that's going to start writing the image to this device. Now, as I'm mentioning, like every target's a little different, but with Avocado, we want to be able to abstract some of that away from the users. We want the provisioning procedure to kind of be, using the same sort of APIs. Where all these devices need to be provisioned. So calling Avocado provision for a target knows how to be able to handle that specific target. For a Raspberry Pi 4, for example, the SBC, you might be burning an SD card, right? And you'll use the SD provisioning profile. And that'll write all the bits to your SD card and then ask you to insert it in that and that, right? For other targets, like the Jetsons, it would be like the USB as well. Every board's a little different. We kind of handle that abstraction behind the scenes for you. So it's really cool.
So
So we're
we're
just
waiting.
playing the waiting game. Do you have any good jokes while you wait? This is when you, right?
Matt had a question on extensions equaling image layers. Anything to say on that? Like,
Extensions are basically, yeah, they're like images, and systemd, when you point it to the extensions, it'll overlay your root file system with that fragment, giving you that unified perspective. So they are shipped as like file system images, as those layers. It sounds a lot like how Docker works, but in the case of Docker leans towards isolation. And
hmm,
sometimes that can feel like you're trying to program microservices on an embedded device. Also, there's extra overhead. This does not have the penalty of the extra overhead. This is all basically giving you that unified, integrated perspective, right?
very cool. So we'll have the Kubernetes demo on the next episode. Just kidding. Let's
We,
roll. I think we're good.
yeah, we're all programmed up here. So this is telling us that we're ready to go. Now, what I'm going to do is I'm going to remove the power. I'm going to flip that device back, and I'm going to flip that boot switch back to the mode to run it in regular mode, um, and then plug the power back in.
I need the little the ding when the images are ready, where that's got to be a new feature.
And
Avocado ding.
I'm gonna go back to my full terminal here. You'll see that we're booting up on the right here now. I do have this a console cable connected here, and this one you have to connect it to the Raspberry Pi headers. But you can see that on the right we're booting up, and we've got a prompt. And if I go back over to the device, we boot it up into a browser, and there we've got the Avocado, nice avocadolinux.org webpage, right? And that's it. I mean, from here, we did this all with. Mm, that is a great question. Yeah. So we do the CLI does depend on Docker under the hood to be able to do containerization for you with the SDK. We put all of the state that you're accumulating for each run into a Docker volume and associate it with that project. And then we what we do then is um, we get uh, um, we get the Docker volume mounted in under opt, and that ties the whole system together. So we're leaking a little bit of the inside of the container paths back out to the CLI, and that's something that we're tracking, and we're looking to be able to patch up as well. So.
Very cool. So what's next? Where would you go from here?
From here, I mean, what we can start doing is like you can do hardware in the loop development. I think that would be a cool thing we can show a little bit of as well. So let's take a peek over at this example, and we can see that what we do is we bring in this development extension, and the dev extension itself is. Um, bringing in all of what we need for hardware in the loop is the server and everything. And so if I take a look over at our setup, what we can do is I've got a window here where we can start up a server. We can see we can SSH into the device if we want to. So that's all up and running as well. And let's say we wanted to be able to add something to this application, right? So inside of here, I can say avocado, Hiddle, uh, server, and I'm going to serve the extension in here as well, right? Oops. Once again, if I can just type, you'd think I would know how to spell avocado by now.
We need the ZSH extension.
Yeah. That's going to bring up the server, and then on the device itself, we can actually mount something in. So if I go back over here to the serial terminal and I log in, we've got like the dev extensions installed, so we can log in as root real easy for development purposes. Don't ship that in production. And on the device itself, we do have Avocado control that you can ask for the status. You can see what extensions are mounted and running. And what we can do with Avocado control then is Avocado control hardware in the loop. And we're going to mount the application extension. So we'll do -E app, and we'll do -S for from the source. I never remember my address, 192.168.1.38. So we're going to mount that. That's going to now mount the extension over NFS from our running development station, right? And it reloads the extensions for us. So at this point now, what I can do is I can go back to our project and I can say, if we wanted to add like another tool or something, let's say we wanted TCP dump, for example. And so I can add that to my extensions list and then just call avocado install. And that's going to install the new extension. So we can see we added TCP dump to the application extension. And now that that's installed, if I go over here and I say which TCP dump, we have it available to us now. Ta-da, before and after. We can even go so far as to like add new features this way. And now that we're mounted in, like every change that we make is pretty easy to be able to just kind of test. So, if you're developing a user interface with your HMI, you can pretty easily make it so that uh, um, the web page, if it's running off of a server on the device, can kind of like get updated in real time. You can have those assets mounted back locally, or you can even just make it so that you can point the web browser at a local domain and just run development off of your workstation, right?
So we got 4 minutes left. How do you take this and get an image ready to take to the field? So we got one more step, right?
Yeah, yeah. So from here, let's say everything's tested up okay, and we want to just try one more thing out. We can do an avocado build to just produce our new images. And then once we have our new images built, you can do some local deployments pretty easily with one more command, avocado deploy. And you're going to take which runtime we want to deploy into which device. So we'll say all of these devices come with kind of the name of the target, avocado dash the name of the target as their host names to default, totally configurable via extensions. And once we deploy that, it'll update the extensions, and then we even test out what it looks like to be able to ping pong the root file systems and the boot partitions as well. So and while you're in the field, the nice thing about extensions is that you don't have to update the OS if you're just bumping your application. In that case, you can just kind of put down the new application extension image, and just like we saw with the runtime, Avocado Control can just reload the extensions and keep running them that way too. Then, right? So with Avocado Deploy, you can really easily test some stuff out pretty quickly. And then from there, it'll just be a matter of, with our integration with Peridio Core, being able to upload the extensions into the system, and then you can distribute them out further to the fleet as with devices that are connected to the network. So yeah.
Awesome. Well, this is a lot of fun. I'm so excited about this product and where we're going for it, where we're going with it. The one of my favorite demos here is that TCP extension, and something that's near and dear to my heart is allowing folks to bring in their own like observability stack and stream the data to their own backend, things like that. And so you can just imagine a world where you have like a Docker something running locally, you want to pull performance stats back to your own Grafana. That is all very easy and extensible on this base platform.
Yeah, absolutely. Yeah, applications, anything you want to be able to put together and ship, it's really quick and enabling. And to that point too, we really want to be able to see application development teams be able to move quickly and fast away from the cycles that systems integrators have. You mentioned earlier that Yocto's, not something that we're trying to totally replace. We believe that that's really still going to be needed for integrators to do custom work with chip down boards, with SOMs, and what we're providing here for people working in those domains is a pattern that enables application developers and systems integrators to kind of work in their different cycles and loops and not have to slow each other down or become a bottleneck and really let this age of new applications kind of fly off on embedded devices.
Absolutely. Can you pull up that one slide on how people can follow us, get involved?
Oh yeah, absolutely.
Yeah. So we're in active development. Things are moving really quick. We're super excited to talk to anybody who's interested about this product, these patterns, or if you're working together. If you want to join our Discord, there's a link there, just peridio.com, join/r/Discord. And then also everything we're building on Avocado is open source and in the public. And so we've already had quite a few GitHub issues getting flagged. If you've got ideas around future targets, future platforms, please let us know. We're prioritizing it based on the feedback of you and our customers. And then also, we just launched our new development center. So comprehensive docs and guides. We used to have Avocado in one spot, Peridio in another, and we brought it all together to tell the comprehensive story. So please go try out the docs, test it out. We've got the provision, hardware in the loop, and then the side load fully documented. And so you should be able to get started, definitely within Qemu, but also with Raspberry Pi today.
Yeah.
With that, I think we're good. This was awesome. Thank you all for joining. Justin, I think it was 11 minutes, but I slowed you down and we had a couple jokes. So that's
We'll update the slide in post. We'll fix it in post.
That's right. That's right. All right. Well, I hope everybody has a great day. Thank you so much for tuning in, and subscribe and come back next time.
Thanks, everyone. Have a good Friday.